So another cool tool that we're going to look at, it called box plots, right? Or also known as aka box plots and whisker plots. Okay, it's not whiskies plots, it's whiskers plots, and it's not the whiskers from the cat and dog food as well. Okay, so it's used to provide a quick visualization of the data, show some variation. So it's a very good visual tool. Okay, and that's how it's going to be presenting. Okay, so it tells you outliers if there's any outliers, and it creates this image here, which presents the median here, the mean, which is this line here. You have the Q1, sorry, the first quartile, so 25% of the data is here. You'd have the lower limit, expected limit here for the mean, expected limit for the mean in this side here. And you have the third quartile here. So it means that 25% less of the observations that are less than the mean are here, 25% that are more than the mean are here, and here are the confidence limits, right? Remember, we calculate confidence levels, right? It's mean plus or minus confidence levels. So these are the confidence levels, okay? So you can have it in a visual way. You can take a look and see how the data is distributed, okay? So how much variation, what is the average, what are the minimum values, are any unusual values, right? So that's the goal of the box plots, to tell you that. So I can create this kind of image and find out those questions, right? So yeah, here it kind of a little bit more, but you can see the variation going this way. You can see the median here. You can see the confidence level going from 60 to 40, and the mean was 50. Okay, how we're going to do this. So to do this, you have to organize the data a little bit different. So we have in our data set there the data in a different way. We have the data like this, right? You have you can have minutes in shift, you have the part time, and have the processing time. If you put all like this into Minitab, it will work out the part types, not a problem. But we don't have it like that for it doesn't work with Excel, right? So to work in Excel, you have to look at the data like this. You have to take all A's and put in one column, all B's in another column, and all C's in another column. Okay, so first thing, stop this video, create another tab, and put the data like this. So, but since I'm a very nice guy, I actually put that in your tab. So you have a tab called box plots. So you use that one to create box plots. So you have the data like this. You have to be like this. And then you can here go into the insert tab here into the histograms, and you have the box and whiskers here. Okay. You have to create. It will create it automatically since the data is already formatted as we wanted to, and sometimes it creates like this weird way and have like a big space where you have nothing, and then you have you know, all the data clusters somewhere. So you can just do here, right click on the y-axis, click on the format axis, and then you can say okay, I want the data to be from 50 to 62, and now it is kind of better dispersed here, right? So you can see this is part A, this is part B, this is part C. You can see the distribution as the histogram presented to us, that B was more spread out. You can see that on a box and whiskers plot. You can see that B is less spread out. The standard deviation is lower here. You can see that A is kind of in the middle there, right? You can see the confidence interval if they overlap or not, and you can see that a lot of things going on, right? So remember here, what does that mean if the confidence level overlap, right? It means that they can have the same mean. Okay, so if you have two distributions where the confidence interval of them overlap, means that they can have the same mean. So you cannot say that they are statistically different than the other. But if the confidence interval don't overlap, okay, you can say that they have a different mean. So it's with 95 confidence level, right? So we're going to do an exercise in class about that as well, but keep that in mind, okay? If the confidence level of two samples overlap, you cannot say that they're different. If they don't overlap, means that the mean of one could be the mean, cannot be the mean of the other one, right? So if they don't overlap, it means that the means are different. Okay, remember we calculated the confidence interval on that Excel file, and that is important, right? So here you can see that A and C don't overlap, A and B overlap, B and C, it's hard to say if they overlap or not. I have to take a look at exactly calculate the data here. We're going to do that in class. But that's important, right? To say if part A, part type impact in processing time, right? So we can say that part impact in processing time because the means are different, especially from A to C. Okay, that makes sense. We're going to do a little bit more of those problems in class, but I just want you guys to have that information ahead of time. And here's just the box plots with the Minitab. Everything that we see in Minitab you have on your class notes or here in your slides, the how to do it, okay, the route to do it, but I'm gonna record a video only for Minitab. Everything you need to do about Minitab in one video or maybe two. So Minitab graph box plots with category of variables, processing time as y variables, blah blah blah. And you can put these symbols as you want it, okay? And it will give you an image like this one.